Are you looking to upgrade your AI so they can modify the environment around them? Maybe you want them to be able to explode or destroy some objects that would open up new paths for them to reach their destination. In this video, you'll learn how to make your AI destroy objects that are in their path to getting to some particular destination, including avoiding paths that would take too long to break down those obstacles. Hey, Chris here from LlamAcademy, here to help you. Yes, you! Make your game dev dreams become a reality. Today's part 37 of the AI series, where we're going to take a look at something brand new. We're going to take a look at how to make our AI attack objects that are laid out in our scene. Objects that are specifically destructible. We've done a bunch of things so far in the AI series, but this is something that I think is really cool, where we can make our AI more interactive with the environment around them instead of just avoiding areas, chasing the player, that kind of stuff. Now they can actually change the environment that they live in. This is obviously a more advanced topic than we cover a lot of the times, and I'm not going to go step by step with writing all of the code. I've already written the code in this one, and what we're going to do is show an overview of how does this work. You can of course check out the GitHub repository, linked in the description below, that has the full project code that you can run on your own machine. Now, as with most things in game development, there are many ways to achieve this. The way we're going to specifically look at doing it today is we're going to make the AI agents, whenever they change state, so we're going to use a state machine for our AI behavior. Whenever the enemy changes state into the chasing state, which is basically the movement walking around state in this example, we're going to start a coroutine that's going to check around them in the direction they're going to see, is there something destructible blocking their path? You might think that's kind of weird and ask, Chris, but if there's something blocking their path, how do they path through it? Where you're going to check in the direction that they're going to hit that destructible object? Excellent question you would be asking in that case. What we're going to do is set it up so that the destructible objects are not included in the NavMesh bake. What that means is on any object that can be destroyed, we're going to make it so it's not included in the build. What we're going to do instead is put a NavMesh modifier volume underneath that object, include that in the bake, and change the area type to something like destructible. That's more expensive to consider whenever we're doing pathfinding. That way the agent will consider in their pathfinding, should I go through this object or should I go around to get to that destination? Then once we detect something's in our path, what we're going to do is change state again to I'm destroying something state. We'll start damaging that damageable component. Once it has been destroyed, we're going to change state back to the chase state, where we'll continue on the path we were previously on. And if something else gets in the way, we'll repeat that process again. Of course, there are many different ways that we can achieve this one, but this is just the implementation we're going to take a specific look at today. Before we go any further, I want to give a huge shout out to all of my Patreon supporters. Every one of you is helping this channel grow, reach more people, and add value to more people, and that means more people are making their game dev dreams become a reality. If you want to help support that mission, you can go to patreon.com/LlamAcademy, choose whichever tier you're most comfortable with. You'll start getting some cool perks like getting your name up here in the section, and getting a voice shout out starting at the awesome tier. Speaking of those awesome supporters, I have Raphael, Andrew Bowen, Gerald Anderson, Autumn K, Paul Berry, and Matt Parkin. I am so grateful for your support. Thank you. Let's take a look at this scene. I have a NavMesh agent called Agent that has the NavMesh agent component, an enemy script, an enemy movement script, and an enemy destructible script. We're going to go over what all of these do step by step, but we're not going to actually write out all of the code for this. The code is already written. I have a game object called Floor that has a NavMesh surface and also a NavMesh manager on it. The NavMesh surface is configured to collect objects' children using the physics colliders as a geometry. Nothing looks too special here. I have some walls, but then I also have these destructible walls. If I move those, you'll see that there's a little pinkish purple cut out wherever that wall was. If I open up the navigation panel, which if you don't have, you can go to Window, AI, Navigation, and open that up. On the area section, I've created a new area called Breakable and set the cost of that to be 5. Because it's going to take the NavMesh agent some time to break down all of these walls, we want them to consider that whenever they're pathing. I've arbitrarily chose 5. Depending on how much life these have, you may consider making that a higher value. If they have very low life, maybe it's fine to leave them at a low value for this cost. What this pink area signifies is that this is a different area on the NavMesh that is more expensive than the blue. These destructible walls are prefabs, so in this prefab, you'll see that there's a breakable modifier game object. If I click on that, This is how we're getting that purple area. We're using the NavMesh modifier volume that overrides the area type to be breakable and affects all agents. If we disabled that and rebake the NavMesh, you'll see that this is ignored. That's because on the destructible wall, I have NavMesh modifier to ignore from build because I don't want this actual physical wall to be considered. And you'll see if we just make the NavMesh modifier be override area to breakable, it actually blocks walking through it, so the NavMesh agent would not be able to path through this obstacle. So that's a really key thing here, is that we want the object that is going to be destroyed to be ignored from the NavMesh build, so that way our NavMesh agents will try to path through it. So I'll quickly revert all of these changes and rebake the NavMesh so the NavMesh agent will try to walk through this destructible wall. Looking back at the destructible, we have a destructible object script attached that whenever it dies, it's going to play some explosion and has a number of life, which I've set to 10. The final thing here is the health text has a destructible health text display that will show the life of the destructible object. Just to see how all of this is working together, let's click play. We'll see that life comes above the destructible object. We'll actually see if I click maybe down here at the bottom left, the agent's going to not go through those destructible walls because they're very expensive to go through. They're going to go the long way around instead. However, if I click straight up to the top left, that's going to be a little bit cheaper than going all the way around. So we'll see the NavMesh agent walks up to each of these obstacles, stops moving, the obstacle eventually breaks, it loses life, and then it goes away. I obviously don't have any attacking animation, but they're sitting there attacking. And that works for all of these destructible objects regardless of their life. There's one more thing I want to show as part of them being destroyed that's really important. Remember, there's a purple area underneath the destructible wall saying that this is a breakable object area and it's more expensive to travel through. After a wall is destroyed, we don't want that to still be there. If I go up to the scene view and click on the floor, we'll notice that after the objects are destroyed, the NavMesh is actually rebaked so that the NavMesh agent will travel through there. If we don't rebake the NavMesh after each one of these is destroyed, the agent will path very strangely because it's going to think that those breakable objects are still there. Let's take a look at how all of this works together. Let's start with the agent. The agent has an enemy script that has a state. So we're using a primitive state machine here to control the enemy's behavior. I'm following a very similar pattern to what we did in AI series part 11. So if you haven't checked that out and you don't know how this works, I have the full explanation there where we have an agent going through different states about wandering, idle, and chasing. Link in the description, card on the screen. All that's happening here is we have some state and we raise an event anytime the state has been changed. The enemy movement just allows us to left click to move the NavMesh agent. It's a little bit more complex than things we did in AI series part 1 and all of the other click to move videos in the AI series. First off, we're using the new input system. So we're using mouse.current.left mouse button was released this frame instead of input.keyup. And we're doing the screen point to array using the mouse current position read value instead of input.mouse position. You also have a line to make sure that the agent is enabled because we disable the agent whenever they're attacking. So before we set destination, the agent has to be enabled. Finally, we're setting the enemy state to be chase whenever they're moving. And at the very end, if the agent is enabled and they're very close to their target position, we will then change the state to be idle. Before we get into the enemy destructible, because this is the most complex piece, let's look at the destructible objects. The destructible object is a mono behavior and it implements the iDamageable interface. iDamageable interface just has take damage, and so we implement that in this class. You already saw that there's a destroy system and a health, but there's also two delegate functions here. There's onDestroy and onTakeDamage. Whenever we take damage, we'll subtract that damage from the health. We'll check if that health is less than or equal to 0. If it is, we'll make sure that health is 0, just so that way we don't show a negative number for the health. And then we'll conditionally invoke the onTakeDamage delegate function. So remember that delegate functions work the exact same as Unity events in the inspector. They're just a little bit more friendly to write whenever we're dealing with them in C#. So that allows us to assign arbitrary actions or functions to get called whenever this event is being executed. We'll get into who's listening to the onDestroy and onTakeDamage events in a little bit. So after we've invoked the onTakeDamage, we'll invoke the destroy system if it's not null, and then we'll invoke the onDestroy delegate function. Finally, we set the game object to be active, false. Then here's that key where we're doing NavMeshManager.instance.bake NavMesh. That's where we're rebaking that NavMesh after the object has been disabled. So whenever this object is disabled, so is the NavMesh modifier volume that's under it. So we're safe to rebake the NavMesh here. Finally, after we set the game object to be active and we rebake the NavMesh, we're going to destroy this game object. Remember that destroy happens only at the end of the current update loop. That's why we're disabling the game object, because that happens immediately, and we want the NavMesh to be baked immediately after this destructible object has been destroyed, but not the game object destroyed because that's delayed. If you only do destroy whenever you try to rebake this NavMesh immediately, it will rebake still considering that there is an active NavMesh modifier volume there and will still consider that this is a destructible path. If the health is greater than 0, then we're just going to invoke that onTakeDamage function with how much damage was taken and the health. Since we were talking about the NavMesh Manager, let's go ahead and open that one. It's a very simple singleton mono behavior. We check on awake. If there's one already there, we destroy the new one and log an error so that way we know we've misconfigured our scene. We get a reference to the surface, and we just have one public void bake NavMesh, which will make the surface.build NavMesh. If you watched AI series part 14, 14.5, and 15, you know that there are more optimized ways to handle baking a NavMesh. Since I have a very simple scene, I'm just doing the surface rebuild the whole thing. If you have a more complex scene, then you might want to consider some of those videos to get more information about how to bake the NavMesh in a more optimized fashion. Let's look at the health for the Destructible next. It's relatively simple, and we'll see a simple example of how we're going to assign functions to those delegates. This just has a reference to the Destructible, and we're going to do Destructible onTakeDamage plus equals HandleDamage. Then we have that HandleDamage function that just has the same signature as you saw on the Destructible that accepts an int damage and an int health. And there all we're doing is setting the text to be the health. On the destroyed, we just destroy this game object as well. Technically, that's not needed in this one since it's a child of the Destructible wall. I was initially thinking to do this on a canvas, and I didn't, but if you do have it on a canvas instead or have like a progress bar or something like that, then you would need this callback, so that way you would destroy this whenever the parent object was destroyed, even though in the hierarchy, it's not under that Destructible anymore. Now we're going to get into the meat and potatoes of this one, the EnemyDestructible. We have some serialized fields here, a destructible check rate, because we're going to do raycasting. We don't want to check every single frame. That gets very expensive. So we want to throttle how many raycasts we're doing per second. I'm setting it to 10 by default. Check distance is how far in front of our agent we're going to check for destructible objects. We have a reference to that NavMeshAgent. I think that's pretty clear. And we have some things controlling how fast and how much damage we're going to attack with. And finally, a layer mask about which layers contain destructible objects. I've set this to only be one layer called Destructible. We'll look at that in just 1 second. I've created one new layer called Destructible, and I put all of these destructible objects on that layer. Then we have some private variables that we'll talk about as we use them. On awake, we're getting a reference to our enemy and assigning onStateChange to be HandleStateChange because this class needs to know about what the current state of the enemy is, and we only want to respond to something whenever it changes. In that HandleStateChange, we're checking is the new state equal to chase. If it is, then we're going to stop whatever coroutines we're doing because we no longer want to attack the destructible that we were attacking before if we've started moving again. And we don't want to check for destructible objects because we're just going to start a new one to check for those destructible objects. The check for destructible objects coroutine is a little bit complex, so let's walk through this one at a time. The very first thing we do is yield return null. If you don't wait just a second before you do that, you actually end up with a stack overflow because of some of the state changes that were happening all in the same frame. So this is a very important piece of this. We then define vector3 array corners equals new vector3 of size 2. I've defined it as size 2 because in a little bit, we're going to do agent.path.getCorners non-alloc, passing in this corners array. We only care about the first 2 corners because we're going to raycast based on those 2. And because accessing the agent path corners generates garbage, we're not going to use that. We're going to use the getCorners non-alloc instead. Because you maybe have a very large number of enemies, we want this to be a very optimized coroutine. Finally, we define bool found destructible equals false, and we're going to check while we have not found a destructible, then we do that getCorners non-alloc. We check if the length is greater than 1 because getCorners non-alloc tells us how many corners were returned. The way that works is usually the first corner is where the agent currently is. The second corner is the next kind of corner in their path, going to wherever they're going. If they're going in a straight line, there's 2 corners returned, their current position and the target position. As the agent has more points to go to because they have to make a turn or something like that, then there's more corners in this array. The corners array is just a list of points in world space that the agent is going to travel between. If the length is greater than 1, I have like a triple nested if here. You can combine these into one if you really wanted to. If physics.raycast, passing in where we currently are, so that's corner 0, in the direction of corners 1 minus corner 0, .normalized. That gives us the direction to that next corner. We pass out the raycast hit with the check distance and the destructible layers. If that hits something that returns true, we'll do hit.collider equals try get component destructible object. If that returns true, then we get that destructible populated. That's where we're going to actually start doing something. So we're going to do destructible.onDestroy, adding in HandleDestroy. We're going to set original path, which is a NavMesh path, to be the agent.path. We'll get into why that is in just 1 second. We'll also disable the agent because we're going to make them start attacking this destructible object, so we don't want them to be moving anymore. We're then going to change the enemy state to be destroy. Maybe I could have called it something more like destroying, attacking destructible. I don't know. I chose destroy. Then I'm going to stop this coroutine, the check coroutine, and set the attack coroutine equal to start coroutine attack destructible, passing in this destructible. That's where we're going to actually attack this destructible. And we'll set found destructible to be true and break out of this loop. Let's look at what some of these functions are. HandleDestroy. So whenever the destructible object has been destroyed, we're going to stop attacking. We're going to check if the enemy state is destroy, because maybe some other agent was destroying this one and this one has since started to move away. We've got to make sure that this one is destroying that. We're going to re-enable the agent. We're going to set the agent path to be their original path and change the enemy state to be chase. What that's doing is returning our agent back to whatever they were doing before they ran into this destructible. They're going to go back to the exact same path that they were following before they started attacking this destructible. That's how we get our agent to run up to one, destroy it, run up to the next one, destroy it, run up to the next one, destroy it, until they hit their actual position. Finally, the attacking destructible, all we're doing is defining a wait for seconds wait to be a new wait for seconds based on that destructible attack delay. And while that destructible is not null, we're going to make that destructible take damage based on our attack damage and then wait. I hope that this helps you understand a way that you can implement having destructible objects in the path of your agents, so that way you have a more dynamic environment and more engaging AI with a new state that allows your AI to modify the environment that the player and the enemies are living in. Some other potential options in addition to this implementation that you might consider if this doesn't fit your use case particularly well is, instead of using the raycast directly in the path that we're going at, you have multiple raycasts going in a little bit different directions, so it's not as precise as directly in the line. If you want them to be a little bit more sensitive to being able to get attached to something that they should destroy, you could use physics.overlapSphere to do a very similar process, and even use the dot product to control the field of view in front of the agent to see, okay, anything in this area I'm going to go ahead and latch onto. Since this was a little bit more advanced topic and we did a little bit different format this time, I'd really like to hear your feedback about how did you feel about this format? Did I walk through it slow enough? Do you need more explanations about these things? Or was referencing the previous videos enough for you? As always, if you got value out of this video or the AI series, please consider liking and subscribing to help the channel grow, reach more people, and add value to more people. There's new videos posted every Tutorial Tuesday, and I'll see you next week.